Alright, so now we are going to talk about colloids. So, what we talked about before has been solutions. Alright. And this is stuff dissolved on the atomic or molecular level, like it is individual molecules floating around in something. Alright. So, the solute and the solvent are going to interact on the molecular level. So stuff dissolves, right? It's a homogeneous mixture. And, you know, they have some key features, like they're clear. They might be colored, but they're still clear. You can see through them. And the solute isn't going to settle out. You don't let it sit there long enough and see something settle at the bottom. It stays dissolved, right? It stays interspersed. It stays all mixed together. Alright, well, what else is there then, right? What else could there be? Well, there are also suspensions. I know a thing or two about those. I had a lot of them in middle school. Never in high school, though. And I don't know how you get suspended in elementary school. That's a whole different thing. Anyway, for chemistry, they're a little different. They're still a mixture, but they are heterogeneous. And in this case, it's basically, you shake stuff up and it, gets shaken together. But if you wait long enough, they separate again. So it's a heterogeneous mixture with large particles. In fact, you can usually see them with a magnifying glass. And it also means that the not solution, but the suspension is going to be cloudy. It's not clear, it's cloudy. Plus the particles will settle out. Alright. And so an example of this would be muddy water. So you take dirt, you take water, you shake them up together, and you get muddy water. But if you set if you do it like a jar and you set it on a counter or something, and you come back in an hour, you'll see that the dirt has all settled back down to the bottom of the jar. It's separated from the water. But when you shake it up and it hasn't settled yet, that's a suspension. The dirt particles are suspended in the water. They're not dissolved. They're moving around in the water, but they are not favorably interacting with it, and they're not going to stay dissolved. And it's not individual molecules, it's big chunks of stuff. Okay? So, this section is not about suspensions, it is not about solutions, it is about colloids. So what are colloids? Well, they're going to go in the what else is there section, right? And they're kind of a mix of both. Alright? They're not a solution, they're not a suspension. You got solutions, you got suspensions, and somewhere in the middle here, you got colloids. So they're going to have properties of both. So they are kind of they're between solutions and suspensions. Alright, and so what we have are small particles, but they're not molecules. But they're small enough that they don't settle out. Like, they continue to float around in the water. So it's still, it's a homogeneous mixture, I guess, but it's just because the particles are too small to settle. It's still cloudy. So they're big enough to reflect light, and this is known as the Tyndall effect. And so, fog is a colloid, reflects light. Smoke is a colloid. It's a solid dispersed in the air. Whereas fog is a liquid dispersed in the air. Clouds reflect light. They're liquids dispersed in the air. And the water droplets are dispersed because they're small enough that they don't fall. They're not raindrops. They're small particles, and eventually they will glob together and turn into raindrops, and then you get rainfall. But until that happens, they're small enough that they just float in the air. And they're not a suspension because they're not going to settle out at the size they are. They're colloids. Just keep floating around. So the example, would be something like fog, which is very small water droplets. So again, it's not water vapor. Water vapor would be a mixture of gases, right? It's little pieces of liquid water that are too small to fall out of the air. So they stay suspended. Alright. So there's two parts to a colloid. There's the part that's, the majority of everything. Like with fog, it would be the air. Not all the air is fog, right? Not all the air is water droplets. That would be a body of water. But there are water droplets in it. And so there is the part that is, kind of added in, and then there's the part that's just the whole space, right? And so there's names for these. So you have the dispersed phase. And the names really do just nail it right on the nose what they're doing. What is the dispersed phase? Well, it gets dispersed around. It's going to be relatively minor amount that's present. So it's the one we have less of. So it's typically present in a lesser amount. And so there's more air than water droplets. So fog, the water droplets would be the dispersed phase. What is the other part? Well, it's the dispersion medium. And so that's just what stuff gets dispersed in. It's in the medium, all right? Like this would be the atmosphere. Fog, the air, and fog would be the water droplets. It'd be the dispersed phase. The air would be the dispersion medium. And so it's what the dispersed phase gets, dispersed throughout. You gotta love these circular definitions sometimes. And I'm laughing because I'm pretty sure I did this, not your book. So it gets spread throughout. Or dispersed. So it's whatever the first thing is that it gets spread around in, that's the dispersion medium. Alright, and so again, with fog, fog, dispersed phase equals the water droplets, and the dispersion medium is the air. It's that straightforward. So the last thing we'll say about this, how do you make a colloid? What do we do? Well, we've got two pretty straightforward options and then one sneaky one. All right, so there's kind of three routes we can take here. Option one, you've got big things, they're in a suspension, break them up, make them smaller, and eventually they are no longer a suspension, they're a colloid. So you break up larger pieces, to get smaller ones. Or as I like to call it, you won't see this in your textbook, breaking and shaking. Alright? You gotta break it up and then you gotta shake it, get it dispersed throughout. Alright, and so that means we break up larger particles that would be a suspension into smaller particles. So they're not still single molecule, but they're particles. And then we disperse them by mixing, stirring, shaking, whatever, you know, etc. Whatever we have to do to get them to spread out. All right, break them up, spread them out, disperse them. Number 2, condensation. So if one option is to take big things and break it down, well, what if things are too small to be a colloid? What if they're on a, they're dissolved on a molecular level? They're a solution then, or a solute. What can you do? You can get them to clump together. All right. So what do you do with water vapor? Well, you can get it to clump together, become water droplets. You got fog, you got clouds, you've got a colloid instead of a gas. All right. And so what do we call this trick? Condensation. And so there's just 2 options. You go big to small, break it up. You go small to big, build it up. All right. So it's just going to be the opposite of above. And so it's going to be the idea of getting smaller particles, maybe on the level of molecules, to grow in size. And so, for example, you go water molecules to droplets. You go gas to colloid. Alright. And then the third trick, this one's kind of sneaky, but it's a fun one. Alright. And it's how a lot of salad dressings are made, is emulsify. So you use an emulsifying agent, or an emulsion agent, either one, same name, or different name for the same thing. And what it will do is it will break up one substance and gets it to disperse in another. And that creates a colloid. So an emulsion is a type of colloid. So emulsifying agent breaks up one liquid and gets it to disperse in another. So for example, you have oil plus mustard plus vinegar. I recommend a balsamic vinegar for this, by the way. That's going to get you a salad dressing. So if you put oil and vinegar together, that's like oil and water. The oil is just going to settle on top. You're going to get 2 distinct phases. It's not going to be a mixture. So what happens if you add the mustard and you shake it up? The oil will disperse in the vinegar. So the oil is dispersed. The vinegar is the dispersion medium. And the mustard is our emulsifying agent. Now, I will, big disclaimer, you'll want to add some marjoram or some seasonings of some kind. So this is like the base, all right? This is how you build the canvas, okay? You still need to paint on it. And, if someone's like, actually, I went to a modern art show and I saw several unpainted canvases on the walls. Okay, yeah, well, all right, make a modern salad dressing with just these items. It'll probably turn out okay, but you could make it so much better. You put some garlic in there, some ginger, or both, or whatever. You put some soy sauce in. There's all these options, okay? You can look up recipes online. But they're going to boil down to something like this. Or you can make mayonnaise. So mayonnaise is oil and vinegar, but you use egg whites instead of mustard to get them to emulsify. So there's different emulsion agents. Soap is another example of emulsifying agent. Oh, yeah, I almost forgot. And salad dressing is our colloid. Okay, that's a colloid. You look at salad dressing, it's not clear. Alright. So, where was I? Oh yeah, soap is also an emulsifying agent. And so it gets oil to disperse into water, which is great for washing, right? We have water at the tap. If you just run your hands underwater, they're not going to get very clean. But if you put soap on there, it's going to pick up oil and dirt and all kinds of stuff, and it's going to create an emulsion that dissolves in the water. Or, if you're cleaning a pan and you use dish detergent, it's going to have a lot of emulsifying agents in it. That's going to help get oil off the pan and help it get rinsed, which is different than detergents, which lower the surface tension of the water and help stuff dissolve. So they're different processes. Now there's a whole range of different types of colloids. Like you can have gels and aerosols and sols, all these different options. And I encourage you to look at table 11.4 to see them. There's some good examples there that make sense. And in fact, I'm going to force you to look at table 11.4 to do the practice worksheet. So I will provide that as a supplementary link on the lecture page here. But it's also just in your textbook, so it's not hard to get to. And the last thing I'm going to say about colloids is that colloidal systems, there's a lot of them, it turns out, right? I've given several examples. That table will give even more. So they're not dissolved. This is not a chemical change, this is a physical change. So colloidal systems can be separated through physical processes. You can do filtration. You can filter out colloids. You can have an air filter that'll get smoke out of the air. You can have a dehumidifier that'll also knock out like fog, stuff like that. Temperature changes. If you want to separate the oil and the vinegar in your salad dressing, put it in the fridge. The oil will harden up on top. The vinegar will settle down underneath. And so you actually have to melt the oil and shake it back up when you want to use it. And so that is separating our dispersed compound from our dispersion medium, just through a temperature change. Something as simple as putting it in a refrigerator will do that. Charged electrical filters. Your book talks about these a little bit. So they're something you might have in a room filter or a stack scrubber at like a power plant, something like that. And just like those types of things. So, distillation, whatever it might be, those are all physical changes, physical processes. So these can be separated by them. Alright, well, I hope you had fun this semester. If you have any questions as we close out this chapter, as always, let me know. I will have a course evaluation up as soon as I figure out how to do that. I'll post a class announcement so that you're aware. And this is the first time I've taught this class. At least in the fall of 2020, it is. And so I always appreciate feedback, but for my first group, your feedback tends to weigh more heavily because I haven't made all the changes I want to. So, if there's anything you can think of that I could do better, just let me know. If you're happy with what I'm doing, you can tell me that too, and then I don't have to change, because change is hard, and I appreciate that. So you can just let me know. Or it's great though to know like if something is working, because that I might think something's working, and then I have someone tell me it isn't, but then I have 10 people tell me it is. That type of thing happens. So the more numbers I get, just the better I can kind of read the room and figure out how, if a student is having some complaints about something, it's not that I'm not going to address them, but having that other feedback will potentially help me figure out how to address it in the most beneficial way for everyone. But hopefully you settled into kind of the regular format of the class that I've put together, and that's working. My goal isn't to make you do chemistry a certain way. It's to help you learn chemistry however I can, to the best of my abilities and the best of yours. And so if there's anything you can think of to help with that, I'm all ears. You can tell me anonymously through my review. You can tell me in an office hour. You can, write me a friendly email, nasty email, whatever. Like, however you want to tell me, I'm all ears. And then, like I said, if you do have trouble with anything this week, message me on Canvas, come to an office hour, use the help forum, whatever I can do to help, just let me know. And then next week, review. So, if there's anything you're struggling with, save up those questions. If you had some stuff that wasn't making sense back in Chapter 4, that's cool. We can talk about Chapter 4. We'll do that, I believe, Tuesday, right? You look at the schedule. Double check me on that. But yeah, so good luck, and if there's anything I can do to help, let me know, and I will update you all when I have the evaluation up. All right.